It's pretty wild when you think about how far away these objects in the night sky are. It's downright mind-boggling.
Yeah, to think that most of what we see is way more than trillions and trillions of miles away. So far away, in fact, we cannot even use a measurement like miles to measure it. And that's right, Laika. When we say the universe is big, we mean incredibly, massively big. And those stars are far, far away. Very far, far away. We look at the night sky and marvel at the stars, nebula, and galaxies, just like people have done for ages. We wonder exactly how far away are those stars? Well, today we can compute their distances from us. If you recall from a previous episode, we showed that the light we see is just part of what we call the electromagnetic spectrum, and there are other forms of energy waves that we cannot see, like UV and radio waves.
But they all move as waves. They have different wavelengths, but all move out across space at the same speed. We call it the speed of light.
When you turn on a light bulb, the light actually travels from the light bulb to your eyes. But it happens so fast that it looks like the light appears instantly. But it doesn't.
Let's slow the scene way down. The light from the bulb actually moves across the room from the bulb to Laika.
And we can measure that. Light waves travel at a speed of 186,000 miles per second.
Wow, that's fast.
That's faster than anything. In fact, it's the cosmic speed limit. According to Einstein's theory of relativity, nothing can go faster than the speed of light because, mathematically speaking, it would take infinite energy to do so.
Since light travels, it means that it takes more time to travel farther distances. Our sun is 93 million miles away. If you do the math, you will find that it takes the light about 8 minutes to get here. So when you go outside on a sunny day and you see the sunlight, the light actually left the sun 8 minutes early and flew past Mercury, Venus to get here in just 8 minutes. That's really fast.
Now apply that to the stars. The closest star system to Earth is the Alpha Centauri system. It takes light over 4 years to get here from there. Since the numbers are way too big to use miles or kilometers, astronomers use a different unit, the light year. Simply, that is how far light travels in 1 year.
So just how many miles is Alpha Centauri? Can you figure out that, huh, Hark, Mr. Math Brain? Even Laika wants to know.
Well, let's see. Light travels at 186,000 miles per second, and there are 60 seconds to a minute, and 60 minutes to an hour, and 24 hours to a day, and 365 days to a year. So that means there are 31,536,000 seconds in 1 year. So 31,536,000 seconds times 186,000 miles per second means that light travels about 5,865,690,000,000 miles in 1 year. See what I mean? The numbers get too big. Alpha Centauri is over 4 light years away, so that means it is over 24 trillion miles from Earth. And it is the closest star. Most stars are hundreds or thousands or millions of light years away. The stars in the Fornax system, for example, are 630,000 light years away. Care to do that math? It is, let's see, 3.78 million trillion miles away. Let's just stick with using a light year from now on.
So now we know what a light year is and how we can use it to measure vast distances in space. But there is something else we can do with light years that is really neat. We can look backwards in time. That's right, backwards in time.
Let's look at the star Rigel in the constellation Orion. Rigel is almost 800 light years away, which means it took the light from Rigel 800 years to get here. So you are seeing Rigel as it looked 800 years ago. We are seeing Rigel's past.
Just think about those distant galaxies we can see that are billions of light years away. We are seeing what they looked like before Earth even existed.
And the reverse works too. The light leaving the sun today will take 800 years to reach Rigel. Let's pretend that there is a planet orbiting the star Rigel, and let's pretend that we are on it right now, this minute. If we look up in the sky, we see billions of stars, just like we do here on Earth. But from Rigel, one of those tiny stars is Earth's sun. The sun looks like a tiny star from Rigel because it is 800 light years away. Now, let's pretend on this planet that we have a super duper duper powerful telescope that can not only see Earth's sun close up, but can see Earth close up. Let's look through it. There's the sun, and there's the Earth. Now, let's pretend that this telescope is so super duper powerful that from Rigel, it can not only see Earth, but see the people and things going on Earth. What would we see looking at Earth this minute, right now, if we were on Rigel with this super duper telescope? Well, Rigel is 800 light years from Earth. So, the light that is at this very minute reaching Rigel left Earth about 800 years ago. Through this super duper telescope, you would see Earth in the 1200s, medieval Earth, the time of Genghis Khan.
Crab Nebula is an explode star. It is 6,500 light years from Earth, so we are seeing as it looked 6,500 years ago.
That is why, even though it blew up 7,500 years ago, the light from the explosion was not seen here on Earth until 1,000 years ago. 6,500 years after it really happened, because it took the light 6,500 years to get here.
Looking at the night sky is really looking back in time.
We use the light year to measure distances to objects outside our solar system. But within our solar system, miles and kilometers become very large and light years become very small. So we need another unit of measure. We call it the astronomical unit, or AU for short. 1 AU equals the distance from the Earth to the Sun, or approximately 93 million miles. So the Sun is 1 AU from Earth.
The Earth does not revolve around the Sun in a perfect circle. In January, we are about 91 million miles away from the Sun, and in July, we are just over 94 million. Astronomers choose 93 million as an average number.
So it makes it easy to compare with also. Earth is 1 AU from the Sun, and Jupiter is 5.2 AU from the Sun, meaning Jupiter is over 5 times the distance from the Sun as the Earth is. Another unit of measure in astronomy you will see is the parsec. A parsec is the distance measured by taking 1 AU and dividing it by the tangent of 1 arcsecond degree, or 1/60th of an angular degree. It comes out that 1 parsec equals 3.262 light years. It is just another measurement of vast distance.
So how do we know how far away those stars are, Herc?
One way is using parallax or triangulating a position. Astronomers observe a star and then view it again in 6 months when the Earth is moved to the other side of the Sun and is farthest away from where the original measurement was taken. If the star is close enough to us, it will appear to have moved in relation to the other stars. Then, using geometry, you can determine the distance. You know how far the Earth is moved. Then you can measure the angle of how far the star moved compared to the other stars. Half of that angle is your parallax, which we measure in radians. Using the formula d equals 1 over p, where p is the parallax, we solve for d, which is the distance to the star, in parsecs.
See this yourself. Hold a finger in front of you and close one eye. Now open that eye and close the other. It looks like your finger moved, but it didn't. You can measure how far it looked like it moved. And knowing the angles and distance between your eyes, you can determine how far your finger was. That's how they do it.
This only works with the closer stars. Another way astronomers determine distance is by measuring the star's color spectrum and brightness. From the color, they can determine how bright a star is, but the brightness dims as light moves through space. So astronomers can then compare the brightness of the star as seen from Earth to what it is by the color spectrum, and determine how many light years the light has traveled.
On your sky chart, you will see brightness ratings for the stars. The ancient Greeks originally measured the brightness and called it magnitudes, numbered from 1 to 6. The brightest stars are 1 and the dimmest 6. Today we added to that, and now we even have negative numbers for the really bright objects.
The brightest star in the sky is Sirius, in the constellation Canis Major. Its magnitude is minus 1.6. Without a telescope, your eye can make out stars down to about a magnitude of 6. That is why the Greeks stopped at 6, as they did not have telescopes. Depending on your scope, you can see a lot dimmer magnitudes. But the lower the magnitude, the better you will see it.
So, Herc, if you can't go faster than the speed of light, how'd you get here? A warp in the space-time continuum? Wormholes?
I'm from Earth!
Oh, what a coincidence! You mean that the planet you come from is also called Earth?
I'm from this Earth, here, the one we're standing on.
Yeah, you just keep telling everyone that. Laika and I know better.
Oh, great. Now Laika is against me.
Until next time, happy stargazing, everybody!
Check out our other episodes in the Let's Explore Astronomy series at www.tedcookproductions.com/LEA.
You will find all kinds of cool astronomy topics there.
Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.